Today we are talking about ratios and proportions, and we want to be able to write ratios and write and solve proportions. Start with ratio. Ratio is a comparison of two quantities using division, and here are some examples of some ratios. A compared to B, A divided by B, and you notice where B is located here, so that means that B cannot be the zero. Some ratios that you might encounter in a normal day, we could say miles to hours, or we could say miles per hour. Maybe that one we're more familiar with when we're driving down the road. So those are some examples of some ratios. Ratios should be expressed in the simplest form. So here we can see 12 over 18 is a ratio, but it's not quite the simplest ratio. We can divide both of these, the numerator and the denominator, both by 6, which ends up giving us 12 divided by 6 is 2, and 18 divided by 6 is 3. So that's the same ratio, but that's in simplest form. So when we solve our solutions, we should have our ratios in simplest form. So we have a couple example problems here. In a survey of 300 students, 252 said they have an iPhone. What is the ratio of those without an iPhone to those that were surveyed? So first thing we have to do is we have to find out how many people do not have an iPhone. So there were 300 people that were 300 students that were surveyed, and 252 said that they had iPhones. So what we want to do is, if we subtract these, we will know how many people are left. So 300 minus 252, and that ends up being 48 people that have something other than an iPhone or without an iPhone. So the question asks, what is the ratio of those without an iPhone to those that were surveyed? So we want to make our ratio with without in the numerator. So we're going to put 48 divided by those that were surveyed. So the total students surveyed is 300. So this is a ratio. However, it is not the simplest ratio. So I know that both of these are divisible by 3. So if we divide them both by 3, 48 divided by 3 gives us 16, and 300 divided by 3 gives us 100. Now these are still both divisible. They have common denominator or common factor. In this case, our common factor is 4. So we can divide them both by 4. And we get 4, or 16 divided by 4 is 4. And 100 divided by 4 is 25. So that is our ratio of 4 without compared to 25 students total. So that was the first example. Our next example here. In a schedule of 6 classes, Martha has 2 elective classes. What is the ratio of elective to non-elective classes in Martha's schedule. So again, we have 6 total classes. And Martha has 2 elective classes. And now it wants to know, what is the ratio of elective to non-elective? So 2 elective classes, how many are going to be non-elective? Well, that's going to be the rest of them. So if we say 6 minus 2, and that is going to be 4 non-elective classes. So what is the ratio of elective to non-elective? So we'll still have our fraction. Elective goes first in the numerator, so 2 elective. And we have 4 non-elective. Now this is not in simplest form, so we can divide both of these by 2. Two divided by 2 is 1, and 4 divided by 2 is 2. So we're going to have 1 elective class compared with 2 non-elective classes. We have example 3. The measure of the angles of triangle ABC are in the extended ratio 1 to 2 to 3. Find the measure of the angles. So in this one, we have, instead of having just comparing 2 things, we're comparing 3 things. So we have to go back a couple chapters and remember all of the angles of a triangle add up to 180 degrees. So that's the triangle sum theorem. So we can say 180 is equal to, and we're going to call for triangle ABC, so we're going to have the measure of angle A plus the measure of angle B plus the measure of angle C. So we have all of those added together. Now the ratio is 1 to 2 to 3. And it doesn't matter which one. Oh, it does matter. A is 1. If A is 1, B is 2. If A is 1 and B is 2, B has to be 3. So put 1 here. We're going to put 2 here. And we're going to put 3 here. And those have to be equal to 180 degrees. Now, if we add these together, 1 plus 2 plus 3 is 6. So that does not add up to 180 degrees. But the ratio has to be the same. So the thing that is not going to change for any of these is what x might be. So if we put 1 times x plus 2 times x plus 3 times x, that is going to tell us what our x value is, and then we can figure out what each angle measure is. So we can combine like terms, 1x plus 2x plus 3x, we add those all together, and we get 6x. And that's still equal to 180 degrees. So then we can divide by 6, and we get 30 is equal to x. So now that we know that 30 is equal to x, we can substitute 30 back into each one of the angles, and we can figure out what the value of each angle is. So the measure of angle A is equal to 1x, or 1 times 30. So that is equal to 30 degrees. The measure of angle B is equal to 2 times x. And 2 times x is 60. And the last one, measure of angle C. Measure of angle C is equal to 3 times x, or 3 times 30. 3 times 30 is 90. And if we add those all together, we do get 180 degrees. And then we have our last example for number 4. The measure of the sides of triangle ABC are in the extended ratio of 3 to 7 to 5. The perimeter of the triangle is 156.8. Find the measure of each side. So this is kind of similar to the previous example, except for instead of talking about angles, this time we're talking about sides. And if we're talking about perimeter, we have to add up all the sides of the triangle. So in this case, we have 156.8 is the total perimeter, is going to be equal to the 3 sides added together. So the first side is the next side is BC. And the last side is CA. So the ratio is 3 to 7 to 5. So we can do a similar process where we say 156.8 is equal to 3 plus 7 plus 5. And again, we want to find out 3 plus 7 is 10 plus 5 is 15. That does not equal 156.8. So we have to scale this by the same factor. So if we plug an x into all those, the ratios will remain the same. And then we can solve it similar to the way we solved the one above, where we can combine like terms. So that's going to be 15x. And that's equal to 156.8. And we can divide both sides by 15. And our 15s cancel. And 156.8 divided by 15 is 10.5. So then we can use that value and substitute it back in, and we can calculate what our other values are going to be. So AB is equal to 3 times 10.5 which is going to be equal to 31.5. Then we have BC is equal to 7 times 10.5, and 7 times 10.5 is going to be 73.5. And the last one is CA is going to be 5 times 10.5, and 5 times 10.5 is going to be 52.5. So those were some examples that we went through referring to ratios and extended ratios.